Hey, welcome back to DentChem. I'm Tom, and we're talking about something really important today, carbocation stability. We're going to see a lot of these in organic chemistry. They're usually high energy intermediates, right, determining steps. Just remember, carbocations make 3 bonds. They don't have a full valence shell, so they're going to react a lot. Okay, we're going to see them a ton. Let's start out with our worst carbocation that we can have, and we'll move to our best. Okay, oftentimes we're going to have to prioritize different types of carbocations based on their stability, something we have to know. Our worst carbocation is going to be a primary carbocation. And we call it primary because there is one alkyl group that is donating electron density through induction. Remember, isolated charge is bad. That carbocation is not good. But if I have one group that is donating negative charge to a positive charge, that's going to help neutralize it a bit. And that's why secondary is better than primary, because now we have 2 groups that are neutralizing that positive charge. And tertiary, we have 3 groups. These are electron donating groups that are help, you can think, neutralize or spread out that positive charge. All of that has to do with induction. And if we look at our areas, which we should know, if you don't know areas, there's a DentChem video on it. Be able to explain every single organic concept that you run into in OChem 1 and OChem 2. Explain everything with that easy to know acronym areas. Watch that video. Okay, so through induction, we should know that why primary, secondary, and tertiary increase in stability. Then we get into our best carbocations for a different reason. Resonance. That's going to be our allylic and benzyl carbocations. These are going to be about of equal stability. Some other factors maybe depending on conjugated system size and so on. Blah, blah, blah. Doesn't matter. Just remember, allylic and benzylic are most stable. In both of them, the carbocation is 1 away from a double bond. So carbocation here, 1 away from this double bond, this pi. This isn't quite a pi system. This would be a system here, but think of it as 1 away from a double bond. That's how we're going to identify these. For the same reason, when we're spreading out charge, we're getting more stable. Okay, it's still the reasoning, but we're going to do it in a different way. We're going to do it through resonance. So right there, meaning I can move the positive charge to the right side. And I could do the same thing for this benzene ring. I could move this up here, and my positive charge would be down here to the right, and keep cycling it through. In all of these cases, I'm spreading out that positive charge. The more so I can do that, the lower energy I will be, the more stable I will be. These are the most stable through resonance, remember that? And our tertiary is more stable than secondary and primary because of induction. So resonance is always going to trump electronegativity, but use both of those to understand carbocation stability. Another thing you should know, these factors, resonance and induction, can compound. They can work together. I've tried to give you a good example of that down here. So try your best and identify the most stable carbocation in this compound using this chart up here. Okay, so you've looked at this compound here. You should first prioritize, how can I get most stable? So first I need to be looking for, are there any allylic or benzylic positions here on this compound? I have a double bond. So right to the left of that would be allylic position, and also up here to the right would be allylic position. 1 away from a double bond. There we go. Remember, resonance and induction are compounding. They can work together. So I have my carbocation on the left could be tertiary and allylic, or I could have on the right secondary and allylic. The best carbocation in this case is going to be in this position, not only as allylic, but it's tertiary, best carbocation we can get through both induction and through resonance. There's some more practice back here. I'll link a video of me solving these. We go through them together. But before that, try them on your own. I encourage you to do that. Rank most stable and least stable from these compounds up here and these down here. Remember, induction is not as good as resonance. Resonance is always going to trump induction. Give this video a like, please. Subscribe to the channel. Thank you for watching and thank you for support. Keep OChem free, keep OChem easy. The way to do that is DentChem. Thank you.